Good afternoon, Dr. Colin. Today I take this opportunity to show you my finished assignment number 11, uh, regression analysis. Let me share my screen. So question number 1, use the correlation and linear regression to describe between the API and full. Also report out the predicted mean of API for full 25, 50, and 75. So I was able to export the data which you have provided and use the regression analysis. So I'll start with correlation. So starting from correlation is added two variables, API 00 and full, and sample correlation R is selected, report significant flag, correlated in alt hypothesis, scatter plot, and density with 95% confidence interval. So the correlation table shows R is greater than 0.05, which has a larger effect size, and the P is less than 0.05. So the correlation study reveals that it has a strong relationship between the API and full. The correlation plot, as you can see, the x-axis is full, y-axis is API, and the scores are equally distributed, and the best fit line pierces through. And the API and density we have also exported to show the linearity of the curve, and R has 0.574. So the next phase, we will go to linear regression. So in linear regression, we selected the dependent variable API 00 and covariance is full, and the model will skip statistics. We selected the estimate, confidence interval, tolerance, and the variance inflation factor, model fit, and descriptives. So method specification, we selected the P, and plot is margin and margin effect plots with confidence interval. So in linear regression, as you can see the model summary, it has R is above 0.25, which also has a larger effect size. So the model summary of the linear regression indicates that 33% of the variance in the student academic API can be explained by the variation in the percentage of full. Next is ANOVA regression table. So in ANOVA regression table, it indicates the p-value is greater than or less, p-value is less than 0.05, and degree of freedom 1,398 is equal to 195.987. So for the model M1 full, the ANOVA table shows significant. Next is the coefficient table. In coefficient table, you can see the mean for API is 647.622, and for M1 intercept, which is A, is 185.505, and the slope P is 5.46. So the coefficient table indicates that performance index increases by 5.47 for each unit increase of the percentage for full. So unstandardized shows 5.47 and the P is less than 0.05. This indicates that the one standard deviation is 0.39 standard deviation increases in API. So the result of tolerance and the VIF is also one that shows no correlation, or you can also say no multicollinearity. So the descriptive API and full, you can see the statistical values, and you can see the marginal plot. So in the marginal plot, it has full on x-axis, y-axis as the API, and you can see as the teacher's credential grows and the student scores also grows in an elevated curve. So based on the formula, y is equal to a plus b1x. So as you can see, for 25, 50, and 75 full, so the API is equal to 185.51 plus 5.47 multiplied by 25 will provide the value value. So this is the predicted mean for the API. Good afternoon, Dr. Colin. I'll take this opportunity to show you question number 2 from assignment 11, regression. Let me share my screen. So question number 2, transform the continuous variable for grad school into categorical variable with 3 equal groups. New categorical variable to predict API and report the predicted mean of API for 3 categories of grad school. So the data, this will be the regression between API and the grad school. So the grad school is the percentage of the parent who went to the higher grad school studies. So let me start with descriptive statistics for grad school. So for grad school descriptive, the variable is grad school. We selected all the statistical sample size that shows valid, missing, mean, cut point for 3 equal subgroups, standard deviation, minimum, max, and that shows the descriptive statistics for the grad school. Now the next step will be the linear regression. So for linear regression, we select the dependent variable is API 00 scale. Now it cannot be covariates because we need the grad school into 3 categorical subgroups. So for that reason, we will go back to the data. I have inserted the column on grad school. So I use the code which you provided by using the descriptive statistics, the values and the range between this formula kept it nominal column type, and that yield the label editor from 0, 1, 2. So these values will be used as a group 0, 1, and 2. So linear regression, now the grad school 3 category, and we selected the model for grad school 3 statistics, shows estimate confidence interval for 95% tolerance and VFI model fit descriptive. We kept the P value for method specification and plot. We have the margin effect and confidence interval plot. So model. So the model M1, which is grad school, that shows 0.634, and the R square that shows 0.482. So this shows a strong correlation, and a higher the value is, it has a larger effect size. And when RMSE, when the value is lower, this shows a better fit model. So the sample linear regression found 40% of the variation in the API can be explained by the variation in the grad school subcategories. Next is ANOVA. So the ANOVA model, as you can see, the ANOVA is the P is less than 0.05, which means this model is significant, and with the degree of freedom 2,397 is equal to 133.633. So next is coefficient table. In coefficient table, you saw the M0 API, the intercept value is 647.622, and the M1, this will show 3 different numbers or based on the group 0, 1, and 2 for grad school. So the slope or A, the Y is equal to A, which is the intercept for the Y, which is 561.138 for group 0, and for group 1, it's 64.180, and for group 2 is 210.182. So we have used So the next will be for the collinearity statistics, the tolerance and the VIF is within 1. So that means there is no correlation or multi-collinearity, and the p-value is less than 0.05. So the results of the coefficient table shows the grad school subcategories were positive, indicating that the academic performance increases with each unit of the grad school. So the group 0 is which is 0, the API is 561.114, and for group 1 the same API A, which is the intercept for y, it added to the slope 64.18, which is 625.32, and for group 2 it's get added by 210.18, 771.32. So this has in the margin plot, as you can see in the margin plot, the x-axis is grad school, the 3 categories of grad school, and you have the API scores. So as you can see, each group, the score, API score, as go up, as you explained us in the t value. It's not a straight line, it's like inclined slope by using the coefficient in the coefficient and the t values. And also the last will be the descriptive statistics, which shows the mean standard deviation.